Remember doing this? Parallel lines? Now, right now, can I say that they're parallel lines right now?
No. Yes.
I can?
No.
You could guess, right? You could always guess. But can you say definitively, can you say without a shadow of a doubt that those two lines are parallel?
No.
No, you cannot.
No.
What if I did this?
Yeah, now you did.
Now you can say that they're parallel. Okay. Shh. I got it. Okay. Go. Got two parallel lines right here. This is quick review. Let's just put some numbers in here like we've done. You've seen this before. Should be very familiar to you. Now, if the lines are parallel, watch what I'm going to do. If you have parallel lines, actually, let's do it like this. Let's call this line L and call it line M. So if line L was parallel to line M, right? It's a big if. And that's important because that's what we're going to really talk about today, this if part, okay? It's parallel because it shows that they're parallel. So if they are parallel, then, this is called an if-then statement, right? If this is true, then some other things are true. What do you think I could say about some of these? I'm not going to go through every single possibility. You could say 1 and 5 are equal to each other, right? Because they're corresponding, couldn't you? Okay, you could say 3 and 6 are equal to each other because they're what? Alternate interior angles. Good. You could say that 2 and 7 are equal to each other because they're what? Alternate exterior angles. You could now, could you say that 4 and 6 were equal? No, but you could say 4 and 6 were supplementary because they're what? Consecutive interior angles. So let's list those what? 4, I think there's 4 different ones. So if the two lines are parallel, then every corresponding angle is going to be what? Then the corresponding angles are going to be equal to each other. Agreed? Okay. There's a big if. I'm going to keep saying this because I want you to understand what we're going to do here in a second. If the lines are parallel, okay, which they are, right, because they got the two arrows there. If the lines are parallel, then the corresponding angles are going to be equal. All right, what else? If the lines are parallel, then the what? Alternate interior angles are going to be what? Equal. What's another one? The alternate exterior angles will be equal to each other. And then the last one, nah, we already got corresponding. It starts with a C, though. Consecutive, right. Consecutive what? Interior angles are equal. Oh, no, not equal. I almost misspoke. I did that in my last class. Are supplementary, right. Are supplementary. Okay, they add up to 180. All right, so watch. If they're parallel, what if they weren't parallel? Could we say all that stuff was true? We could. If I had two lines that were, let's do two lines that are obviously not parallel to each other. Okay? Let's do that. Watch. So 1 and 2, they would be corresponding. Are they equal to each other if the lines are not parallel? No, not if the lines are not parallel, they're not. Okay, what does this say? If what? If the lines are parallel, then all this stuff is true. So if we don't know the lines are parallel, can we say all this stuff is true? No, we can't. All right? So that's really important to understand what we're doing here. Okay? Does that make sense so far? That's all review, isn't it? Let's do this. Let's draw a couple more lines. Tell me if these lines are parallel or not. That's it. Can you tell that those lines are parallel? Somebody in the last class said, well, the transversal makes them parallel. Does the transversal make them parallel? No, not at all. It has nothing to do with whether they're parallel or not. Let's say this. What if I do not know? Now, they could be, right? I'm not saying that they're not. I'm just saying we don't know they are. We don't know that those two lines are parallel right now. But, watch this. Let's put those same numbers in here, okay? Same exact picture. But, different information, isn't it? Because I don't know the lines are parallel, correct? So, well, it gives you angles, but it does it say? Okay, so keep going, John. What are you going to say? Like if 3, and what else? Okay, so if 3 was 50 and 6 was 50, so you're basically saying if 3 and 6 are equal to each other, right? So if 3 and 6 were equal to each other, now this is a big difference on what we just talked about. Okay, let's just stick with 3 and 6 right now. We'll do the other ones, I promise. Watch, if we go, if angle 3 equals angle 6. Now this is a big difference, isn't it? What did the other if say? If what? If the lines were parallel to each other. This doesn't say the lines are parallel to each other, does it? This says if angle 3 is equal to angle 6. What do you think might be true about the two lines then? Exactly right. Then we'll call it line L and M again just to be consistent. Then line L is parallel to line M. Do you see that? Do you see the difference compared to what we did before? What's the difference? Before it said if what? If the lines are parallel. Okay, so we knew at the beginning that the lines are parallel in the other one, right? But this time we don't know the lines are parallel. But we do know that these two angles. Now, what's true about angle 3 and angle 6? Why do we care that angle 3 and angle 6 are equal to each other? Because they're what? They're alternate interior angles. Exactly right. Okay, they're alternate interior angles. So, let's do a general statement then. Instead of saying 3 and 6, we could say what? If the alternate interior angles are equal, right? So if the alternate interior angles are equal, then what do you think might be true about those two lines? Then they're going to be parallel. Exactly right. Do you see the difference between this and what we did before? We just took the if and the then, and we just switched them, didn't we? Okay, so instead of saying if the lines are parallel, then the alternate interior angles are equal, what did we do? We flip-flopped it. We said if the alternate interior angles are equal, then the lines are parallel. Good. Okay? What else do you think we might be able to say about this? Kind of starting a little pattern here. So if the alternate interior angles are equal to each other, then the lines are parallel. What else do you think we might say? If what? Okay, good. Let's go if the alternate exterior angles are equal to each other, then guess what? The lines must be parallel. Get it? What else do you think you can say now? Now we got a little pattern going. If what? What about the corresponding angles? What if the corresponding angles were equal to each other? What if I said that 3 and 7 were equal to each other? What do you think then I could say about the two lines? That they're parallel. Exactly right. All right. So if the corresponding angles are equal to each other, then the lines are parallel. Let's do one more. Keep scooching up and down here. What about 4 and 6? If they're what? If they're supplementary, right. If they're supplementary, or they do what? Angle 4 plus angle 6. Yeah, make a line, or 180 degrees, right. Okay. So if they're supplementary, or if they add up to 180, which means they're supplementary, right? Okay, so if that's true, if these two angles right here are equal, or I keep saying that, if those two angles are supplementary, then what do you think might be true about those two lines? Yeah, they're parallel. Okay, follow the pattern, right? So if what? The consecutive interior angles are what? Supplementary, right? Not equal, but supplementary, then guess what? The lines must be parallel. So let me give you an example of what they're going to do in the book here. I closed my book. Let's open it up again. What are we? 3-5, right? All right, let me find that example. There it is. So let me draw a couple things. This is the kind of stuff that you'll be doing on your homework. So it looks like you had a line. Looks about like that. Then a line about right here. And then you had a transversal. We'll stay with our red theme. Uh-oh. Change that one. Let's change that back to white. Okay, there we go. So I've got two lines right here. Now watch what they do. They give you a couple angles. They say this angle right here is 5x plus 7 degrees. Alright? And then they say this one down here is 7x minus 21 degrees. Everybody see which angle they're talking about? They're talking about this one right here and this one right here. The question says this. Find the value of x so that these two lines, we'll call it L and M, so that these two lines L and M are parallel to each other. So I want to find the value of x in order to make these two lines parallel, because we don't know these lines are parallel just yet, do we? But what can we do with these two angles in order to make these two lines parallel? Michael? Make them equal to each other. Exactly right. So if I set them equal to each other, then I can find what x is. That x is going to make these two angles equal. And if these two angles are equal, they're alternate interior angles, then guess what's true about my two lines? Then they're parallel to each other. Okay? So let's set them equal to each other. So 7x minus 21 equals 5x plus 7. And let's solve for x. Subtract 5x from both sides. Add a 21 to both sides. I know I'm going a little fast, but you should be able to do this. Just algebra. And that's 28. Divide by 2, and x is what? 14. So x is 14. So if x is 14, that means that this angle and this angle will be equal to each other. If the alternate interior angles are equal to each other, then the two lines are parallel. Make sense? I'm going to show you one other type of problem they give you to do, because on the worksheet you have two different types of problems. One looks like this, and then another one looks kind of like this. Oops. Okay? Now watch what they do here. Oh, bell's going to ring in a second. I taught this in the other class. So if you go to YouTube, to the third period class, this will be on here. Let's just do this. What if I said this? What if I said that angle 2 was equal to angle 8? Watch, I'm not done. Don't pack up. Look, angle 2 is equal to angle 8. We'll call this A and B. We'll call this L and M. Which two lines must be parallel? Let's listen. Let's listen.
A and B.
So 2 and 8, they're alternate interior angles, aren't they? So which two lines must be parallel then if 2 and 8 are equal to each other? A and B. Because those are the two lines formed by 2 and 8. Everybody see that? So that's the kind of stuff. Two types of problems. That's one of them. The stuff we did earlier was another one. I do a little bit more with this in the third period class. If you're interested, have a seat. In the third period class, I go through that. Don't leave before you get a worksheet, please.